This session is a continuation of the Chapter 5 review, starting with Problem 16. In Problem 16, we're asked to decide whether enough information is given to prove that triangle WXZ is congruent to triangle YZX using the hypotenuse leg congruence theorem. If so, write a proof. If not, explain why not. So, taking a look at this, we can see that this is a right angle and this is a right angle. Therefore, this triangle WXZ, and triangle YZX are in fact right triangles by the definition of a right triangle. And we're given that this leg, WX, is congruent to ZY. Now that's all we need is the hypotenuse to be congruent, and in fact we can see that ZX is shared by both triangles, so yes, there is enough information to show that these two triangles are congruent by hypotenuse leg, so let's go ahead and do that. Alright, so I've put up a little table and I've gone ahead and written in the given values. So I know that this side is congruent to this, and these two angles are right angles. That means that triangle WXZ and triangle YZX are right triangles. That's the definition of right triangles. I like to abbreviate. Okay, so we know that these are right triangles. I also know that this segment is congruent to itself. So I know that segment ZX is congruent to segment ZX. That's the reflexive property. Property of segment congruence. And so I now know that we have the leg and the hypotenuse congruent, so I can say triangle WXY is congruent to triangle YZX by hypotenuse leg congruence. And now on to problem 17. In problem 17, we're asked to decide whether enough information is given to prove that the triangles are congruent using angle-angle-side congruence theorem. If so, write a proof. If not, explain why not. Problem 17, we're given angle F is congruent to angle J, angle E is congruent to angle H, and FG to KJ. Now, since we have two angles here and a not included side, that is angle-angle-side, angle-angle-side. So this proof is going to be relatively trivial. So let's just go ahead and write it down. So we've drawn in our table, and we have angle E is congruent to angle H, angle F to J, and FG is congruent to KJ. Now that's all that's left is to say triangle EFG is congruent to triangle HJK by the angle-angle-side congruence theorem. Pretty basic proof. And now on to problem 18. So in problem 18, we're given that segment UT is congruent to QR and angle T is congruent to angle Q. Unfortunately, there's no other information given. We have no parallel lines, no other angles, so we lack information in order to be able to prove that these two triangles are congruent at all, let alone to prove with angle side. So our final response is no, there is insufficient information to prove the triangles are congruent by angle side because we only have one pair of congruent angles and one pair of congruent sides. Now on to problem 19. Problems 19 and 20 are similar to the other ones. We're asked to decide whether enough information is given to prove that the triangles are congruent using angle side angle congruence theorem. If so, write a proof. If not, explain why not. So, in 19, we have triangle LPN and triangle LMN. So we're given this angle is congruent to this, and this angle to this. And these triangles share side LN. So it looks like we have angle, side, angle, angle, side, angle. So yes, it does appear there is enough information. So let's go ahead and try to prove this. Okay, so I've built the table and written in angle PLN is congruent to MLN. So PLN, MLN, and LNP is congruent to LNM. So these two angles and these two angles. That's given. Now let's commence with our proof. We know that LN is congruent to itself. So LN is congruent to LN, and that is property of segment congruence. So I now have this side congruent to itself. So I have angle, side, angle, angle, side, angle. So we can say that triangle LPN is congruent to triangle LMN by angle, side, angle congruence. And now on to problem 20. In problem 20, we're given these two triangles, triangle WXZ and triangle YZX. The only thing that we can see is these two parallel lines are going to cause this angle and this angle to be congruent. The other thing that's obvious is ZX is congruent to itself. So we have an angle and a side. But because we don't know that these two sides are parallel, we can't say that this angle is congruent to this, and therefore we can't use angle side angle to show that these two triangles are congruent. So our official statement is no, there is insufficient information to prove the triangles are congruent by angle side angle because we can only show one pair of congruent angles and one pair of congruent sides. Now on to problem 21. In problem 21, we're given these two triangles, and we need to show that angle K is congruent to angle N. So they're not given to us as being congruent, but what we are given is this side is congruent to this side to this, and this angle to that angle. So clearly we have side, angle, side congruence working here. Side, angle, side. So we should be able to show that these triangles are congruent by side, angle, side, and then by extension we'll be able to show that these two angles are going to be congruent. So let's go ahead and start that process. So here we're given that angle J is congruent to angle M, J to M. Side HJ is congruent to MN, HJ to ML, and JK to NM. Now, this shows that these triangles are congruent by angle side angle. So we can say triangle J, K, H is congruent to triangle M, N, L by side angle side congruence. Now I don't put postulate or theorem. This current author shows that this is a theorem. It's also a postulate, and so I'm just saying side angle side congruence to distinguish it from similarity theorems. So now that we know that these two triangles are congruent, we can say that any of the corresponding parts of these two figures are going to be congruent. So we can say that angle K is congruent to angle N by C, P, C, T, C. Corresponding parts of congruent triangles are congruent. The definition of congruent triangles. And that explains 21. And now for problem 22. So in problem 22, we have this rather complex looking situation, and we're tasked to plan a proof that angle 1 is congruent to angle 2. So taking a look at this, again, with the process of trying to absorb as much information as possible about the figure, we can see that this side is congruent to this to this. That makes QV congruent to itself, and these two triangles then would be congruent by side, side, side congruence. And then I notice that this angle and this angle are vertical angles, and this angle and this angle are vertical angles. So given that this triangle and this triangle are congruent, we can show by CPCTC that these two angles are congruent, and by extension, using vertical angles, that this angle and this angle is congruent. So let's go ahead and try that. And so let's walk through this proof. So we're given that segment SV is congruent to UV, SQ to QT. So this to this, and this to this. That leads us to QV being congruent to itself by the reflexive property of segment congruent. So let's go ahead and mark that there. And then, because these are all congruent segments, we know that the two triangles, SQV, is congruent to QTV by side, side, side congruence. Now, because these two triangles are congruent, any of their corresponding parts must also be congruent. So we can say angle QSV, so QSV is congruent to QTV by CPCTC. Because those two angles are congruent, that leads us to these two angles. We can see that angle QSV is vertical to angle 1 and QTV is vertical to angle 2. So we've stated that here. That's the definition of vertical angles. And because those two angles are vertical angles, we know that QSV is congruent to angle 1. So QSV is congruent to angle 1, and QTV is congruent to angle 2. Now, we can see that we have a transitive property situation set up, because angle 1 is congruent to QSV, and QSV is congruent to QTV, and QTV is congruent to angle 2. We have angle 1 is congruent to angle 2 by the transitive property of angle congruence. If you want to follow that through again, you can rewind this video. It's angle 1 to QSV, QSV to QTV, QTV to angle 2. Therefore, angle 1 to angle 2. A little bit more complicated proof, but a good exercise. So after you've gone through this, I would suggest try to do it yourself again. And now on to problem 23.